What's up everyone? I hope you all having a great stress-free day. In this video, I'll be going over a little bit of bone histology as well as anatomical features found on long bones. Out of all my videos thus far, this material definitely may be the most complex. However, I am hoping to simplify things so they aren't as difficult. Maybe they'll bring some comfort to you guys. So with that, let's go ahead and begin with the lesson. Throughout a bone's lifetime, it is constantly being broke down and reformed. Its old mature bone tissue is absorbed and it's replaced with new bone tissue. This process is known as bone metabolism. In this process, there are three types of cells that are involved in this continual cycle, and they are osteoblasts, osteoclasts, and osteocytes. This table shows each cell and its role in bone metabolism. Osteoblasts are responsible for the secretion of collagenous fibers and ground substance. This is called osteoid. So ground substance and collagenous fibers, both of those together form osteoid. Osteoclasts over here are multinucleated cells in charge of absorption of old bone tissue. This old bone tissue can also be damaged bone tissue as well. So they absorb both old and damaged bone tissue. Finally, osteocytes or osteoblasts, these up here, they are osteoblasts that are entrapped in the osteoid that it secreted, so they're unable to move. These cells are located in osseous lacunae, and later in the video I'll explain what osseous lacunae are. And those are the three cells that are responsible for bone metabolism. Now, having just learned their functions, it may be difficult to visualize these processes. So here's an image that will help illustrate this cycle. You can see the osteoclast, which again is assigned to absorption of old or damaged bone tissue. And following close behind it are osteoblasts. The osteoblasts are laying down new bone tissue through osteoid. They secrete osteoid, which ultimately forms into bone tissue. Now moving on to this image, you can see the line of osteoblasts continuing their secretion and filling up the space that was absorbed by the osteoclast. What I like about this image is the osteoblast that got stuck in the osteoid it secreted and therefore becoming an osteocyte. And you can see osteocytes throughout all the bone right here. And that's it as far as the microscopic level of what osteoblasts, osteoclasts, and osteocytes do. Now we can go ahead and move on to the bone cross-section. Here we can see a bone cross-section model. The first anatomical feature that we need to cover is this landmark right here. It comes in a circular shape. This anatomical landmark is called an osteon. An osteon is characterized by two different traits. The first one, and the most important one, is this little channel right here. This is called the central canal of an osteon. Now the second characteristic of an osteon are these layers. And these layers encircle the central canal of an osteon. Those layers are called osteonal lamellae. If you want to just specify one layer in particular, eliminate the E and it'll make it singular. Lamella, it just means one. Lamellae is plural. Another way you can say osteonal lamellae is called concentric lamellae. Again, lamellae means layers, and concentric lamellae and osteonal lamellae are the same thing. Since we're on the topic of layers, we could see here in this bracketed area, and then right here, we have all these different layers, including these right here. These are just protruding out to make it more three-dimensional. These layers encircle the outer surface of the bone. And we know the outer surface of the bone is most external. And since they encircle the circumference of the whole bone, these layers are called external circumferential lamellae. Lamellae again meaning layers. So these are just the external circumferential lamellae, which just means the layers on the external circumference of the bone. Just like the external circumferential lamellae, we have these layers down here in the innermost part of the bone cross-section. These layers represent the internal circumferential lamellae because they cover the circumference of this cavity right here. That cavity that is lined or surrounded by the internal circumferential lamellae is called the medullary cavity. In the medullary cavity, there's various things within it. There's red bone marrow, there's yellow bone marrow. There's just a variety of different things that can be stored there and produced there. But all we need to know is that this space is called the medullary cavity. Now, the last set of layers that we need to learn and identify are these that are surrounded by the osteons. You can see all these different layers. These layers once were osteons, but osteoclasts came by, absorbed them, and osteoblasts came soon behind and secreted osteoid, forming a new osteon. So you can tell that this section right here is older than this osteon right here, and that this osteon right here is newer than this osteon because it's overlapping it. So these layers that are found in between the osteon are called interstitial lamellae. The only difference between interstitial lamellae and an osteon is that interstitial lamellae do not have a central canal of an osteon. So for example, right here we have this section right here, and we have all these layers. Since it doesn't have a central canal of an osteon, it has to be interstitial lamellae. These right here are osteonal lamellae because it still has a central canal of an osteon that it's surrounded. These layers right here, again, interstitial lamellae because there's no central canal of an osteon. Now let's go ahead and clear all these notes so that we have room for the next notes. There is a white layer right here, and it's also demonstrated in this image right here. This layer is a specialized connective tissue proper that's called periosteum. And it is literally the outer surface of a bone. And what keeps it attached to the bone itself is with these fibers. These fibers bind it to the bony tissue within here, and these fibers are called perforating fibers. They can also be seen in the image that we were just on. This right here, those are all perforating fibers. And again, this white outer layer that's being bound by the perforating fibers to the external circumferential lamellae is called periosteum. Peri means surrounding or around. It's a prefix, and that's what it means. Well, that's going to help us learn the next term. We also have another layer of specialized connective tissue that lines the medullary cavity. That layer is called endosteum. Endo mean within, which makes sense because it's the deepest layer found in a bone. Again, let's return to the other image. We have several different channels going on. We know the name of this channel right here. This is the central canal of an osteon. And it has all these different types of vessels coming in it. It's not just blood vessels, there's nerves in there, there's lymphatic vessels, there's a bunch of things going through the central canal of an osteon. But the same goes for these channels right here that go deeper and deeper, deeper into the bone. These vessels come through an opening on an external surface of the bone. That opening, or hole, is called the nutrient foramen. And those can be seen with the naked eye. They're quite large. Through the nutrient foramen, you enter this long passageway, like I mentioned before. And this passageway is called the nutrient canal. And there are hundreds of these. And what they're doing is supplying nutrients to living cells. To explain the next landmark, I need to go ahead and erase some of these markings. Just like I mentioned, the nutrient canal supplies several different vessels that give nutrients to living things within the bone. And when I say living things, I mean cells. These black little dots that look like little spiders, those are osteocytes. And if we remember, osteoblasts that are entrapped within the osteoid that they secrete become osteocytes. These black little cells are osteocytes. They're entrapped in these little pockets. And you see these spaces right here? These are the pockets that they're entrapped in. These little pockets or cavities or whatever you want to call them, those are called osseous lacunae. Lacuna is singular, lacunae is plural. So these are the spaces where these cells reside. You see these little finger-like projections coming off of them? Well, those aren't little legs of the cells. Those are actually little channels leading up to the cell. These channels are called osseous canaliculi. Osseous canaliculi help nutrient and waste exchange. Nutrients comes through blood vessels that are found in the nutrient canal and the central canal of an osteon, and nutrients goes to the osteocytes amongst other cells, and waste is dumped back into the same vessel to be taken away and be discarded elsewhere, which is really cool. So the way I think of it is that the canals flow to the lakes. Osseous canaliculi flow to the osseous lacunae, which kind of sounds like lakes. So canals flow to lakes. That's how I remember it. Let's look at more examples of osseous lacunae and osteocytes in the other image. Again, we have these little spaces right here found throughout the whole model. And again, those are osseous lacunae. And all these little lines kind of connecting them all, those are osseous canaliculi. And if you want canaliculi in the singular form, it's going to be canaliculus. Lus singular, li plural. Good. Here we have more osteocytes that are just hanging tight because they're stuck inside the bony tissue. And the osteocytes are receiving nutrients thanks to the nutrient canals that have vessels that allow them to have nutrient and waste exchange. So again, osseous lacunae or lacuna for singular. All these little lines are osseous canaliculi, canaliculus for singular. And these black little spider-looking thingies are osteocytes that are trapped within the osseous lacuna. Before we move on to the next part of the video, I want to answer frequently asked questions that I've seen from students, like, what are these giant cylinder pyramid-like things? These cylinders are just representing osteons. Right here, we have an osteonal lamella that is closest to the nutrient canal, and it just works its way out to the most external osteonal lamella. You can still see osteocytes within the osteonal lamellae. Here, same thing. Osteonal lamellae working its way towards the central canal of an osteon. These projections right here are just different layers of external circumferential lamellae. Those sometimes confuse students because they're just sticking out and they're not like the rest of the model. All they're just trying to show that osteons continue their way up, because this is just merely a cross section, and that there's several layers found within osteons themselves. Perfect. Now we can go ahead and move on to long bones. In this image, we have a long bone. More specifically, we have the radius. Now, in developing long bones, we have some terms that help us identify a certain position of that long bone. So first, let's just go over with the basics. At the proximal most end, right here, as well as the distal most end, these two ends are called epiphyses, or epiphysis for just one. So right here, we have the proximal epiphysis. And then down here, we have the distal epiphysis. Now, whether you put proximal or distal in front of it, that's up to you. It helps things become more clear on what you're really indicating. But as far as an official term, proximal and distal is not part of it. So epiphysis is just fine and acceptable. The next part we have is this whole body. So you can just think the body of a long bone is called the diaphysis. Now in this image, this bone is mature. It has completed its growth. But when a long bone is developing, it doesn't look like this. Instead, it looks like this image right here. You can see that the red arrow is pointing to a space. Well, in reality, there isn't a space. Instead, there's cartilage. And so since cartilage isn't as dense as bone, it's not shown in the radiograph. So this space right here actually has a pretty cool name. It's called the epiphyseal cartilage. So this area right here, it's called an epiphyseal cartilage. Another acceptable name for epiphyseal cartilage is just physis. Those words are interchangeable, epiphyseal cartilage or physis. The region just beneath the epiphyseal cartilage or the physis, so this region right here, in a developing long bone, this region is called the metaphysis. I'm going to write it over here. Metaphysis. As the bone develops, the epiphyseal cartilage will soon ossify, and there will no longer be a physis. So technically, the metaphysis no longer exists in mature long bones. However, physicians and surgeons sometimes refer to the space where the metaphysis once was continues to be the metaphysis. So sometimes you'll see an instructor or a professor point to a mature bone and say this is the metaphysis, and that's fine because the metaphysis used to be in that location. So let's quickly review. The cap or the top of each long bone, both bottom and on top, we have the epiphysis. And there's one on the superior end of this image as well, because this is the distal end of the radius. And finally, all of the body of a growing long bone, and even a mature long bone, it's called the diaphysis. And those are all of the parts of a growing long bone. So right here on the ulnar side, we can see the ulna, and we can see the diaphysis again, the metaphysis, the epiphyseal cartilage or physis, and finally the epiphysis. And this applies to all long bones. So you can see right here, we have epiphyses. These 4 metacarpal bones don't have an epiphyseal cartilage or a physis. However, this one does. You can see this space right here. And one last thing before we end this video. Occasionally, the epiphyseal cartilage, although it becomes ossified, sometimes a line remains behind. In this case, that line that remains behind is called the epiphyseal line. So you can just eliminate the word cartilage and put in the word line. That is only if there's a line that remains behind in a mature bone where the epiphyseal cartilage once existed. And that is the end of our video. Those are all the terms that you need to know for the parts of a growing long bone, as well as the cross section of a bone. And I hope to see you guys next time. Take care.